In this video, guys, I am going to introduce you to meta-analysis, which is a way better way of doing literature review as compared to individual studies. Now, many researchers are moving toward meta-analysis because when they do meta-analysis, they have better chances of getting published in a reputed journal. So, just to begin with, let's understand what exactly meta-analysis is and how you can apply it. So, meta-analysis basically combines the results from different studies. So, just to give you an example, suppose this is individual A, and similarly, there is another individual B. Now, what happened? These two individuals actually studied something. So, suppose they studied whether fintech can influence financial inclusion. So, fintech refers to something like a firm which offer digital payments or P2P lending, like your PayPal or PhonePe or Paytm. And financial inclusion refers to people who are actually using the services of bank or digital payments in order to make payments. Basically, they are using banks to save their money or doing transactions. So, it's like individual A finds that fintech do influence financial income, while individual B says it doesn't. So, they two have different results. And now we don't know actually which study is true. So how do you find it? Suppose I can say this study was done in US and this was done in India. So do you know now exactly which study is true? Or what weights should you assign to a study? Which study is better so that you assign a better weight? Well, we don't know because it could be this study is false positive, or the other study which is done, this could be false negative. So by false negative, it means the study wrongly indicates that this has been a particular condition which was absent. So, and when I say false positive, it could be like basically the formula for false positive, which we covered in machine learning classes, is FP by N, which means false positive upon false positive plus true negative. So it could be that this study was actually wrongly reporting the result as compared to what actual results are. So in this case, we cannot actually predict what is right. Okay. So then what is the better method to do it? Because we are performing meta-analysis, we should know what weight to assign to study. Because meta-analysis, I already told, but I'll write it here for you also. So it's actually combining the results of individual study. So in this case, if we want to combine, we should be able to assign weights to these studies. And if the results of these studies are different, then how exactly we can assign weights, which one is better or not. So let's see what other method can be we use in order to assign it a weight. All right, so let us understand how exactly weights are calculated. So I'll write weights. Now, in order to understand which study should be given more weight or which study should not be given higher weight is based on precision. So, which study is more accurately predicting the result closer to reality should be given more weight. Now, how does this precision comes? In statistics, precision comes by two things. One is sample size. So, if the study's sample size is large, I can say this study is more precise and I can assign more weight. Similarly, variability. So, variability, it refers to how closer to the average value your data points are in a distribution. So, if your data points are very close to your average, then variability is less. That means that study is more precise. So based on this, so now just suppose both of the studies have same sample size. So I cannot use this. Similarly, if I'll say both of these studies have same variability, then I can't use this also. In this case, I have to find other ways of doing it. So what is the other way, or what exactly in addition to individual study I'm getting from doing meta-analysis? That is something we need to move on to. So what exactly it does? It actually help us with moderators. So what are moderators? Now we have a separate video on this. We have explained all the types of variable, mediators, moderators, and control variables, and other types of things, which actually explain this. But for this one, moderators are basically those variables which influence the strength of the relationship. So if I say your quantity demanded is influenced by prices, basically your law of demand, then moderator is something which actually strengthen that relationship. So when price rises, you demand less of a product. Moderator is something which actually influences this. So probably a climate control. If there is a different type of climate, so probably summers, then if price decrease, you'll buy more of ice creams. And if hot weather is there, then you'll buy more of ice cream. So what exactly it is doing? It is actually strengthening the relationship between price and quantity demand. Your weather is actually strengthening relationship. So that can be a moderator. Another example for moderator in our study, which was in basically on fintech and financial inclusion example. So it could be bank, or it could be internet connection also. So if your internet connection is stronger, you will make digital payments. You will use more of phone pay or Paytm to make payments, and that is why the relationship between usage of digital payment is increasing due to internet connection. So it is a moderator. It is actually influencing the end result. So that is why we do meta-analysis, because it helps us with moderator also. And moderator is basically some variables which are strengthening the relationship. So I can write it allow us to assess the relative influence. What allows your meta-analysis? All right. So let's move on and understand what other benefits meta offers over individual analysis. So let me add a new word to it. So to begin with, again, and understanding why meta is used, basically why we combine individual studies, it is to get an overview of the field, and that overview is quantitative overview, not anything else. So that means we are using quantitative mathematical overview. That is why we use meta. But quantitative overview we can also get from individual studies, evidence-based studies, right? So let's see whether we get it, whether we don't get it, or whether there is an issue with individual studies which meta is solving, or it's just hype. Okay. So let's see. When you do an individual study, what do you get? You get a result in either yes or no, and this result is based on p value. Okay. But what if you do meta-analysis? In meta-analysis, we get average of true effect size. So what is true effect size now? Because these are statistical terms. So let me explain here. It basically, when we have two groups, and if I am offering a study between two groups, and I am actually judging the average outcome. So probably suppose in group one, I am giving a medicine to them, and in group 2 I'm giving a placebo, basically a sugar pill, and I'm finding out whether the what is the effect on this medicine on the two groups, where one believes it's a true medicine and is getting a true medicine, while the other is believes it's a true medicine but getting a placebo. So in this case, I will have average outcome in two groups. That is basically the difference between them is your effect size. So I can write down this definition for effect size so that you can better understand this. So it is the difference between the average outcome, and this is between two groups. So now when I'm getting average outcome of true effect size, instead of getting a yes or no based on p value, which one would be better? Of course, meta analysis. So that is why it is used more. And also another good advantage of, okay, I'll just this thing. Also good advantage of this one, it can help us in identifying moderators. And these moderators can address heterogeneity. What is heterogeneity? So basically heterogeneity is individual characteristics. So suppose somebody is living in rural areas, or somebody is actually belongs to higher income group. These type of individual different characteristics moderators can address, and this can actually help us in finding out the effect size better. And this type of analysis an individual study cannot provide. So basically, it can help us. Meta can help us in finding out the right moderators, which can explain the part of heterogeneity between effect size occurring between the two groups, and this type cannot be helped with individual study. This type of reading cannot be done. So that is why meta-analysis is used more. All right. So let's understand two other things which are very important from the meta-analysis point of view. So I'll just add a new board to us. So in meta-analysis, what happens? In meta-analysis, we are combining different individual studies. So when we combine different studies, we actually know the right method for getting the highest effect size. So what it can help us with, I can write choosing the best method, because I know all individual studies. While combining them, I know what method they have used that can give us the highest highest effect size. So that is the best advantage. I can actually find out the highest effect size method, and then I can appropriately use only that method. Another biggest advantage is prospective power calculation. Now this is a statistical term, so give me a second and I'll explain to you what exactly this means. So suppose I know there is a defect, and I know the likelihood of this defect coming up. I can get the number of observation required to get this defect. So suppose I have likelihood to defect affect when it is there. So basically what it means, I just underline this. Yeah. I know the likelihood to defect, and I know this defect will be there or when it is there. Then using this defect occurrence, basically, we can have number of observations, or I can say sample size, or I can say participants. I'll just put slash here. Yeah, sample size or participants Basically, I can find out required with probability. Suppose I can, I'll say 70%. So basically, what does this statement says? I know there would be a defect, and I know it would be 70% chances of being getting a defect. Then I can actually find out the number of observation required to do the study. That is also what meta-analysis helps. So that is what prospective power calculation means. All right, I think that is all for this video. I'll see you in the next one, and then we will deal with more of things we can do with meta-analysis and then how we proceed with it in practical way.